Welcome to today's webinar. The topic today is using AI with Rfem 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the Dlubal website, the German and English webinars, newsletters, and so on. I will be the moderator today, and I will be supported by my two colleagues. Dogukan Karatash will be the presenter today, and Michael Kraus will answer your questions during the webinar. You can ask questions via clicking on that button here with the question mark. Then you can enter the question here and press the send button, and we will get your question and we will answer you. Okay, that should be all from my side. I hand over to Dogukan. Yeah, Dogukan, it's your turn.
Thank you, Andreas, for the introduction, and a welcome from my side as well. I'm excited that we will now explore the application of AI in structural engineering, and this webinar will be divided into 4 parts. We will start with a brief theoretical background on programming and the use of artificial intelligence in structural analysis. The main part of this webinar will focus on the proper use of our new digital assistant MIA, which you may already know. Another highlight will be the automatic creation of Rfem models with OpenAI and ChatGPT. Finally, I will give a brief outlook on our future vision in the development of Dlubal Software. So let's dive into the topic of what artificial intelligence actually is. We discussed this in a webinar last year, so I will only briefly touch on it here. From my perspective, there is a disparity in the popular representation that AI is about robots, programming, or futuristic scenarios you can see on the left side. In reality, AI often involves programming, as we may already know, in connection with APIs and web services. This is what we want to explore further today. AI is not a robot or another form of intelligence. Rather, it's based on mathematical algorithms that we now want to use in structural analysis, just like other forms of mechanics and mathematics. Why should a structural engineer bother with AI at all? We could ask AIs like ChatGPT if they could help us build a sustainable concrete bridge over a river. At first glance, the images generated may look realistic, showing a concrete bridge or a steel bridge with concrete elements. However, upon closer inspection, you may wonder what some of these supports are doing in the middle, or why there are ends of beams or columns floating in midair. So while AIs appear powerful and generates realistic images, they still have significant technical shortcomings that we want to address, or at least understand how to address them. We also want to see how we can use these tools in the field of structural analysis with Dlubal Software products. I would like to emphasize that using AI makes sense only if 3 conditions are met. 1, I have data about my problem. 2, this data describe an existing pattern. And 3, there is no simpler model available. We must remember that whenever there is a simpler model that adequately solves the job, there is no added value in using AI. We assess whether a simpler or existing model is sufficient and whether the patterns and data are available. This assessment falls to us as structural engineers. Therefore, AI is a combination of knowledge from computer science regarding algorithms and significant input from structural engineering, because we can assess the data, models, and the patterns. In our previous webinar, we focused more on explaining certain algorithms in machine learning and deep learning. We saw that machine learning can be divided into classification, regression, and clustering. We also introduced and repeated that the deep learning is a subset of machine learning that exclusively deals with various forms of neural networks. Another difference is that in machine learning, the problem's features are determined by humans, whereas in deep learning, finding suitable features is done by neural network itself. A consequence of this is that the machine learning typically requires fewer data because humans do the work of feature extraction, while deep learning saves this human step at the cost of requiring significantly more data. The amount of data required depends on the problem. So, for example, classifying an image of a car requires many different images of cars for the neural network to learn the mathematical function that maps the image to the label car. This problem will require thousands of images. In contrast, a simple relationship like stress-strain in a linearly elastic material will need very few data points because a line can be uniquely defined by 2 points, right? And an AI will need only those 2 points to learn the line's equation. When should AI be used in civil engineering at all? So we have thought about this because at Dlubal, we need to justify why we want to incorporate algorithms. We concluded that AI makes sense in 4 situations. So if any empirical models are used anyway, and 2, when a physical model is incomplete, such as when modeling errors exist or more complicated mechanics and physics are involved. 3, when dealing with databases. 4, when we can save time through, for example, parametric modeling or optimization. Now, to interact with the AI and the Dlubal Software products, we need to have some programmable interfaces like APIs and web services. We already held some webinars on this topic, and an API is simply an interface that allows you to communicate with software through a defined set of rules and protocols. And web services are a type of application programming interface, so it's a type of API that distinguish itself from other types of APIs based on their style and way of communication. Web services facilitate XML-based information exchange between systems. In our case, we use a HTTP technology called Simple Object Access Protocol to establish this connection, which provides a standard method for accessing web services. Our team has already developed frameworks that enable the use of this connection in structural analysis and design. These frameworks provide basic functions that allow our users to send commands to Rfem or Ashtab and then receive some responses. They are designed to be user-friendly, so even users with minimal experience can use them effectively. You can find these libraries in our GitHub profile. In the interest of time, I will keep it brief here. I want to ensure you understand that we will use the web interface, the web service and API for the application with the AI. Next, I would like to explain our first type of AI application at Dlubal, our support assistant MIA. I want to give you an opportunity to understand more about the background and application of MIA. Recently, we have learned that some of our customers may need some additional training to use MIA correctly. Basically, MIA is a chatbot based on generative AI, specifically a language model from OpenAI. Generative means that in these AIs, a process generates different answers each time the same question is asked. This MIA with the generative AI backend has been trained using our data from FAQs, our knowledge base, or our manuals, for example. We have embedded MIA both on our website and in our programs to reach the widest possible customer base. Here is an example video showing how MIA appears in our Rfem and Ashtab programs. On the right side, you can see MIA's blue box. You can start MIA by clicking on the small icon. The window can be moved and resized. In the white text box, you can type your question or comment. For example, here I asked, why is Dlubal Software the best in structural analysis? MIA starts generating a response live based on our data. You can follow the response interactively For example, most probably this answer is coming from some of our FAQs. And then the response can be also copied using the copy button. You will also find a link to the source that I mentioned, this FAQ, which I will discuss later. And there will be some buttons for like and dislike that you can give some feedback to Mia. Hey, this answer is correct or not. As you can see, you can have a whole conversation with Mia by reading the answer, asking further questions or commenting, and Mia will respond accordingly. As you can see, there is the like and dislike button, copy button, and here is the resource, and you can further have some conversation with Mia, like here. Yeah. This interaction is basically the same in our homepage, dlubal.com, where you can start Mia by clicking on the small button. The process is identical to within the programs because the AI chatbot in the background is completely same. Here, I will make it a little bit faster. As you can see, Mia is generating the response, and also she will give you some resources to go. Okay. Yeah. So some concept about large language models I would like to discuss a little bit. We have trained Mia with our own data, and you can interact with Mia accordingly. The art of this generative AI chatbot, like Mia, is to ask it correctly. This will be the focus on the next few minutes as I explain the background to large language models that lie behind Mia. As mentioned, a language model is a neural network, so we are in the realm of deep learning. Since we want to generate responses with some linguistic variation, we are dealing with generative artificial intelligence. Language models in AI have a long history, but the recent trend is large language models, so LLMs, which are fed with millions of data points and have general knowledge that can be required, for example, as chat language models. We don't need to go further into these technical details for now, only to understand this, some terminology. I think tokens are essential. Tokens represent chunks of text converted into machine-readable units. Understanding tokens is important for Mia effectively because tokens are the first step in how a computer understands a language. For example, a sentence is converted into a certain number of tokens. The number of tokens varies by the language also. For example, English is very efficient, requiring fewer tokens than other languages like German. Knowing this helps you understand how to interact with Mia effectively. Here is an example. A text with 364 characters might be converted into 106 tokens. The number of tokens required for different characters varies across languages. As I said, English is efficient, needing around 120 tokens for the same amount of text. That might require significantly more tokens in German. Why is the number of tokens important when interacting with Mia? Things like spaces or special characters in the text influence how many tokens are used. For example, adding spaces between words or using different punctuation can change how the AI interprets the text, even if the data remains the same for us as humans. With this knowledge and the background, let's move on discussing how to communicate effectively with Mia. Before diving into prompt engineering, which involves crafting the right prompts for a language model, I want to explain how Mia is integrated into Rfem and Rasshir'te and our website. Mia is built on a knowledge base that is converted into embeddings, which is the language model needs to understand texts. So, as you can see, the user interface, for example, in Rfem and Rasshir'te or on website. Functions are provided that access these embeddings and generate tokens based on the questions asked. delivering responses through an interface. Now let's move on to the main part of this presentation, effective prompting, or how to ask MIA the right questions. Prompt engineering consists of several parts, four of which have already been handled by our team to address technical aspects that you don't need to worry about at all. You just need to focus on the actual interaction with the language model. In the background, we first described to the language model what it is responsible for, how it should behave, the type of output expected, and so on and so on. We provide some context in which the chatbot should operate and set various technical parameters in the neural network. Let's look at how this description and the instruction to the language model and then the specific questions. I have colored some of the parts for clarity. We have explained MIA's role, provided a description which is more detailed than what fits on this slide, given some context related to the structural analysis, and set parameters for terminology, calculation approaches, and materials in mechanics and mathematics. This does not limit MIA, but guides it on where to start searching for generating answers. Then the actual query is presented, like asking how to apply a surface load in Rfem. Because prompting is so important, we have created a dedicated guide in our FAQs based on our experience since MIA was made available. I invite you to review the prompting guide on our website, which clearly explains how to craft your prompts. Let's practice a bit. The goal of prompt engineering is to create precise, comprehensive, and effective inputs to get high-quality answers from MIA. This is more of an art than science, with entire courses dedicated to it. For Dlubal Software, the key is to follow these 5 rules when asking some questions to MIA. 1. Use complete, short, and clear sentences. 2. Make implicit information explicit, as the AI won't infer context on its own. 3. Provide as many details as possible for precision. 4. Break longer prompts into manageable steps and ask questions in a sequence. And 5. Place the most important information at the beginning or at the end, as language model prioritize these positions. With this knowledge, let's look at an example before moving on to live demos. Here is a poorly written prompt. I'm looking for a user why they can't log in. This lacks specify and context, resulting in MIA not understanding the question. A better prompt would be a user can't log into Rfem, not on the home page. This prompt is more specific, and MIA can provide the correct answer. Let's try another example here. Many people ask for help with model instability. A prompt like, my model is unstable, what can I do? Lacks specificity and context, resulting in a very general response here, as you can see. But here, if we specify which program we are using, and my model in Rfem 6 is unstable, what can I do? Then MIA can give us a more accurate and brief, as you can see, answer here. Okay. Now let's move on to another aspect. MIA can provide analytical formulas. For example, if you ask for the analytical formulas for a simply supported beam under uniform load, MIA can generate the maximum shear force and the moment formulas. Additionally, MIA can calculate these values for a specific number, such as you can say beam length of 10 meters and the uniform load of 5 kilonewton per meters. MIA will then provide the step-by-step calculation to you. As you can see, she's providing the formulas of maximum shear stress and the bending moments. And after, I'll say, okay, what happens if there is a beam 10 meter long and a uniform load of 5 kilonewton per meters? Give me the results. And she's providing the, here. She's providing the formula, as well as she's calculating with the values that we gave her. So here is the answer. Yeah. Okay, so with this understanding of proper prompting, please remember to give feedback on MIA's responses. MIA learns from your input, so it's important to let us know if a response was helpful or not, and provide details on what was good or what was missing. This feedback helps us improve MIA over time. So let's move on to the automatic creation of the models with GPT and OpenAI. I will do a live demo here. What you have to do is create an OpenAI account and then find the key and then download the files for ChatGPT Tank and then open the file ChatGPT Tank E as English, and then you can further try. So here's the example that we prepared using OpenAI API and Rfem 6 API. We integrated them together to create a language-based model creator for Rfem. What we have done basically is that we used few-shot learning method to grant the ChatGPT's new model GPT-4o to, for example, have to create a cross-section, a thickness, or maybe a geometry and stuff like that. Now we're going to try to use this bot to help us how to create an Rfem 6 API script to prepare a model. We can run our bot. Okay, so my bot is alive. I'm an AI bot that will help you to define your Rfem model. Okay, so here is my Jupyter notebook to define the Rfem 6 API. First, I'm going to initialize my model. This will create a new model in Rfem called ChatGPT Tank. Yeah, the model is created and the connection has been made, so it's locked. Okay, and then this is my general prompt describing my model to the bot. Let's give this description. I click enter and my bot says, okay, now we can continue defining the different modules of the Rfem model. And I'm going to begin with the material and I'll say material is steel S235. Click enter. And my bot says, okay, here how you define a material. I'll copy and paste it to my Jupyter notebook. Then the geometry, and I'm going to tell geometry, create a circular cylinder with a top lid with a height of 5 meters and a diameter of 2 meters. And I'll give some more instructions like just create 2 circles at the top and bottom and connect them with a line on perimeter. Also, to get the results, I have to tell something about the supports. So I'll tell the bottom circle should be supported. Okay, let's give this instruction and take a look at the output. What it does is create 4 nodes, 2 circles, and 1 line and one line spot. Looks okay, but I have to try also. I'm going to copy and paste this too. Before trying, let's just define everything and then we'll see. Also, I would like to get some help for cross sections. So cross section is the thickness of the lid should be 5 millimeters, and the thickness of the tank wall, or maybe shell or wall, yeah, doesn't matter really, should be 3 millimeters. Okay, my board says this script defines the thickness. Okay, let's copy and paste it. Let's see. No, so 2 thicknesses and 2 surfaces looks pretty good. But we'll see, and let's go to the loads and get some help for loads. Create me a snow load on the top of the top lid, and with a magnitude of 0.25 kilonewtons per square meters, and ignore the self weight. Let's take a look at the outcome. 1 node case, self weight false, and the surface load. Okay, let's copy and paste it too. Okay, so everything's ready. Let's run it one by one and take a look at the result, if it's correct or not. So material created, geometry created, cross section, loads, and then I'll apply it to the model. And my model is created. Let's check. Yes, surface and it's supported. Looks pretty nice. And then I'll calculate it and get the results and see if it's correct or not. Let's start the calculation. Mesh generation is started, as you can see. Then calculation is going through. Yes, the calculation is ready, I think, and then I'll tell, okay, what is the maximum equivalent stress on the walls, and I'll run it, and it says 16 megapascal. So yeah, this was the example I wanted to show you, that how you can use it's not pre-trained actually, it's called grounded ChatGPT model used by few-shot learning method to create a bot for yourself, that how you can use GPT to create some alpha models here. Okay, that's that, and I'll jump into the our presentation now. Yeah, here is another example video, shows a web application we created by GPT and Rfem, which generates some models with conversations also. Like I say, create a 40-meter long steel beam with this material, this section from this point, and then when I click create, a new model is going to be created here. And this large language model is going to create the Python script, and the Python script is applied to Rfem. Then yeah, we can make some changes, some updates. Okay, it's now 5 meters and begins from 0, 0, 0, and here you can see it's done. Looking ahead, Dlubal is working on its own language model, trained with our data to generate some code on textual descriptions. This will allow us text to model interaction directly within our programs, making the process more efficient. And we also have other plans to integrate AI to our program for optimization tools. Yeah, that's all from my side. Thank you for your attention and participation. It was a pleasure to present this topic. If you have any questions, please feel free to contact us via email or maybe our GitHub page. Thank you and see you soon.
Thank you, Dogu-Khan, for this presentation. Maybe an additional hint from my side, you can book your free online appointment, such as a product demonstration or something like that. Just contact our sales team by clicking that button here or that link, or you can scan the QR code and you will get, for example, your free product demonstration of our programs, Rfem 6, RStup 9, R section, R wind, or the add-ons. Okay, that should be also all from my side. Thanks again, Dogu-Khan, for the presentation. Thanks to Michael for answering the questions. Thank you for your attendance. I hope we meet each other in a future webinar. Have a nice rest of the day and bye-bye.